All right, in this video, I want to give you an introduction to game theory, and I want to try to make the case that it's worthwhile to learn, and so let's just get started. So, what is game theory? Game theory is the study of interactions between competing players. Now, the players don't have to actually be people, and it is not the study of, we're not talking about board games or card games or something like that. We're talking about when two people or two countries or two businesses, two entities, we're going to call those things players, when they interact with each other, what kind of behavior are they likely to do? So it's the science of strategic interdependence, of optimal decision making given constraints and incentives. So we're going to look at some examples where there's two players could, and we're going to look at how they will behave if they have certain incentives. How are they likely to behave? What are the rational decisions they'll make based on the constraints and incentives that they experience in the game, which is just the situation that we're analyzing. Okay, so a game consists of these components. It's got to have a collection of decision makers. We call them players. Again, people, companies, countries, entities, organizations, groups of people. Okay, the possible information states of each player at each decision time. So what does each player know? Which does each company know? Which does each country know at different times? We take that information into account. All right, the collection of feasible moves. These are decisions, actions, plays, moves, whatever it is that each player can choose from in each possible information state. So, who is in the situation? Who's in the game? It's players, right? What information do they have? What could they possibly do? Right? And then a procedure for determining how the move choices of all the players collectively determine the possible outcomes of the game. So then we analyze all the possible outcomes given those first three constraints. And then the preferences of individual players over these possible outcomes, typically measured in utility or payoff. So basically, of all of these outcomes, what does each player want to happen? What is the best outcome for them? Okay. All right. Here's a classic example of game theory. And before I get into the examples here, I really want to emphasize that game theory is a way to see the structure in what's going on in interactions between, again, people, companies, countries, organizations, whatever. Okay? So understanding the structure, understanding what sort of behavior might happen given certain incentives and constraints can help you make predictions about their behavior, can help you make better decisions as well. And so this game theory applies from the macro, which is here we're looking at two superpowers and nuclear weapons, right? Or it can go right down to the individuals. And so let's just talk about this classic example here, mutually assured destruction. So what we have here is a chart. It's called a game matrix. And on the side, we have the United States, and on the top, we have the Soviet Union. And given that they each have a bunch of nuclear weapons pointed at each other, each side has two options. So the U.S. can either not shoot first. In other words, if the USSR shoots first, then we would shoot second. Okay, so we can not shoot first, or we can strike first. We can nuke them first. Okay, the USSR, the Soviet Union, has the same options. All right, and then when we put these into the matrix, what we see is that the don't shoot is good for the Soviet Union. It's good for the United States. If the U.S. shoots first, it's bad for the USSR. Okay, but that would immediately result in a the Soviet Union would retaliate and immediately nuke the United States back. If the Soviet Union shoots first, that's obviously bad for the USA. And if they both shoot at the same time, that's bad for both of them. So from the matrix, we see that there are four possible outcomes, and the outcome that is the best for each of them is that they each don't shoot. Okay, again, because if one shoots first, the other one retaliates immediately, resulting in this basically the lower right-hand corner of the matrix where both countries have been annihilated. Okay? So this is one reason that mutually assured destruction held up for so long, or held up, I guess, to this point in history, is because it was good for both sides to not be destroyed. Okay. Now, here's an example of a classic example called the prisoner's dilemma. All right, here's the situation. There's two people, two prisoners. Let's call it call one Adam and prisoner B we'll call Beth. Okay, so Adam and Beth. All right. There's been a crime that's been committed, and they're being interrogated in different rooms. And the people that are doing the interrogators, make a deal. They say, okay, look, prisoner A, Adam, if you betray, you'll get 0 years in prison. All right. And if prisoner B doesn't say anything, so if Beth doesn't say anything, you'll get 0 years, and Beth will get 15 years in prison. All right. If you stay silent and Beth betrays, in other words, and Beth says, turns on you, then you'll get 15 years in prison, and she will get nothing, no years in prison. If you both turn the other one in, you'll each get 10 years in prison. But if you both remain silent, you'll only get 5 years in prison, okay, each of you. And so you look at the game matrix here, and you see that, man, the best of the 4 options is for each of them to stay silent. However, if Adam, for instance, decides to stay silent, he's running a huge risk, because if Beth turns him in, he's going to prison for 15 years. That's the most of all of the possible outcomes. So rationally speaking, he shouldn't stay silent. He should try to turn Beth in, hoping that Beth will stay silent. Now, if Beth doesn't stay silent, if Beth also turns him in, it's still good for Adam, because Adam will get 10 years as opposed to the 15 that he was risking if he stayed silent and Beth happened to turn on him. Okay? Now, this is if the prisoners can't communicate. If the prisoners can communicate, well, then this changes a lot. Okay? So we find in this game that communication or lack of communication makes a big difference, because if Beth and Adam can communicate, then they would both say, hey, let's each stay silent here, and we will just take the 5 years, because we won't turn each other in. All right. So the prisoner's dilemma applies to countless situations in just day-to-day life. I mean, just the you'll have to trust me. We'll get into it more later. All right. Here's another example of game theory. So, zero-sum games versus non-zero-sum games. A zero-sum game is a situation in which one person gains whatever another person loses. Okay, so sports are a good example. So I score, if we're playing basketball, if my team scores a point, that's a point that you don't get. Okay, that's 1 point against you. Chess, every piece that one side takes, the other person loses. Negotiations over a car, for instance, when I get a discount, the dealership loses out on that money. Okay, so whatever I get, the dealer loses. Whatever the dealer gets in terms of an increased price, I lose out on as well. I lose out on that money. Okay, non-zero-sum games are situations in which a win for one person is not necessarily a loss for the other person, or at least not an equal loss for the other person. So a night out with your significant other, for instance. Let's say that you want to see a boxing match. Your wife wants to see a ballet. The best option is probably for one of you to settle, okay? Because you probably value having a good night out more than you value getting to do what you want. In other words, you going to your boxing match, your wife going to see the ballet, not spending the night together probably is a bad date night. And if one of you compromises, it's probably better than the not being together at all situation. Okay, so you can have sort of a win-win situation, although it may not be. You might end up going to the ballet despite you wanting to go to the boxing match, but you'd much rather do that than not spend the evening with your wife. Okay. Here's another example. Small business can invest $1,000 back into the business or donate it to charity. Either might result in immediate loss for the other, but could result in a long-term upside. So for instance, if the business takes $1,000 and invests it back into the business, it's possible that will help them grow the business further, that down the road they'll be able to donate more to the charity. So that's a possible non-zero-sum game or a possible win-win situation, despite a loss early on, what might be perceived as a loss early on. All right, last one we'll talk about is the tragedy of the commons. So here is the situation that was first, where this idea was first put out there. And so it's the idea is that there's this common area where sheep can graze. So a bunch of people have sheep, and each person can let their sheep graze in the common area. Now, there's a finite amount of grazing land, right? So you can't just let all the sheep graze all the time, or you'll run out of grass. Okay, you'll overuse the resource. All right. So the question is, how long should you let your sheep graze there? Well, you might think, well, just enough that everyone has enough stuff. But if you find that there's a benefit to letting your sheep graze more of your sheep, or your sheep graze in the common area longer, let's say that it saves you in your grazing area. So you have some private property, for instance, let's say, and if you take your sheep and they graze more in the common area, that saves your grazing area. You can maybe raise more sheep or something like that. Okay, so you're going to be incentivized to let your sheep overgraze in the common area because it doesn't cost you anything, right? You can just use that resource. So you're taking advantage of it, right? That's clearly a problem, because if everybody thinks like that, then what you have is the resource will get expended, right? And it will disappear eventually. So the tragedy of the commons is another area of game theory that scales to a lot of other places. So for instance, this shows up all the time in environmental policy, for instance. So a business that pollutes the air is polluting a common area, right? They're putting their pollution into something that we all need, the air. And so the problem is that they don't have to pay for that. And so we end up with worse quality air because of the tragedy of the commons. And you'll find this in a lot of examples of environmental policy, but it's not just that. It's anytime there's a common resource where individuals might be incentivized to use it more frequently than what they should to save enough for everyone, for there to be enough to go around. So those are just a few examples of game theory. And I'm recording this in the middle of the coronavirus pandemic here. And I hope that over the next few days you'll see that a lot of the areas of game theory we'll talk about apply to how people are behaving and what kind of decisions are being made from the individual to the governmental level. A lot of those decisions can be explained by different areas of game theory. So that's it for the introduction.